And welcome back. This is the Developer's Guide to Windows 10 Insider Preview. I'm Jerry and this is Andy, and we're talking about adapting your application to different devices. We just talked about adapting your UI and all the different tricks, techniques, and controls that we give you. Now we're going to talk about adapting your code, because application code is not the same across all the devices. You go to your Xbox and you have a few APIs that simply don't exist on the phone. The same thing with HoloLens, the same thing with desktop. How do you adjust and adapt your code so that your application runs as smoothly behind the scenes as we're making your UI look in front of the scenes? And so, Andy, I'd like just to give us a summary of where we're headed so I can get a feel for this, because this is a big topic.
It is, yeah. So we're going to, first of all, just take a look back at the Windows 8.1 story, because we've had universal apps from 8.1. So a look back at what that meant and how apps were packaged and how you built them, how you handled differences in that case, because that sets the scene nicely for talking about the quite slightly different story we've got with UWP. Where we can we've got a broad universal API set which covers the majority of your app needs, but then you can extend it out for particular device families with extension SDKs. There's some coding around that you need to use in order to make sure that the platform-specific code only runs in the places where you intended it to on that platform, so we'll look at that. So there's platform adaptive code, and there's also version adaptive code. So there's two sort of flavors of the same thing. And then we'll just kind of wrap up where we started, really, just talking about how shared projects, the 8.1 model, fits into all of this as well.
Makes sense to me. Before we start talking about Windows 8, let's talk about what an adaptive code is, what the fundamental pieces are.
Yeah, so we've done a couple of modules where we've looked at the design story and the user experience story and about adapting your UI so that it looks good on a phone, or grows up to a tablet, or extends out to even up to big screens like Xbox and the Surface Hub. So that's kind of adaptive UI. We've talked about that, but then there's other aspect to this as well, where you can conditionally execute some code on a specific device that only makes sense on that device. So outside of the core universal API set, we've got these extension SDKs, and that's adaptive code, which allows you to conditionally take advantage of unique device capabilities.
So let's look back at Windows 8.1 now. So there are definitely some challenges that we needed to overcome, and then we did with a handful of strategies, starting with shared code. And so shared code in Windows 8.1 basically meant that what we were targeting were two binaries. So we would create a binary specific for the phone, and we would create one also specific for Windows. And we were creating effectively two applications with as much shared code in between as we could. We weren't really creating a single application.
No, that's right. And in Visual Studio, there were a few places where some APIs were unique and different. So in 8.1 Universal Apps, it was the same. It's the same WinRT API set, but there were a few little bits where we didn't quite align. And classic example there's the hardware buttons back pressed event, which is for the phone hardware back button.
And only the phone.
And only the phone, yeah. And there's a few others shown in the windows.phone.ui.input.hardware buttons namespace there. There's also the camera button. So all the kind of hardware buttons you get on a phone, they had their own APIs and they applied only to the phone. And you could, in Visual Studio, you would be able to drop down and you kind of filtered your view of the code according to whether you were compiling for the desktop target, the Windows Store app, or for the Windows Phone app, the phone target. So those are the two binaries, and you could conditionally look at the code for that to see what it looked like. Now, if with the code you had in an 8.1 shared project, a shared project is simply a project where the entire contents of that shared project is block copied into the projects that reference it. So it's a convenience really for holding one physical file copy of it and then using it in two places and compiling it into two binaries. So you're making that decision on when that code to hook the hardware buttons back pressed event handler. You're making the decision on when that code gets used using as you call it over here, a pound if, or hash if, as we say over the other side of the pond.
That's right.
And that is a compiler conditional. So at compile time, you're saying if we are building for Windows Phone and the Windows Phone project has a compiler
variable.
A compiler conditional variable declared Windows_phone_app. So that would conditionally include that into the binary that's getting compiled. And there's the C++ syntax you can see underneath that.
And so this was nice, but it was also sloppy, right? It felt like after a while you would see your code and not be able to just look at it in an easy way and be able to follow the logic, because you would have these separate blocks again and again. And once in a while it was a great solution, but as we started introducing it, it became harder and harder. So developers started realizing other techniques of shared of partial classes and inheritance, and it actually was quite difficult when you think about having to target multiple binaries, and that's kind of where Windows 10 kind of makes it happy again, where we don't need to chase this anymore.
That's right. So the big deal, looking forward now to where we are with UWP. So the big deal with UWP is that we are compiling one binary from one API set. So
the Universal Windows Platform.
The Universal Windows Platform. So essentially, in theory, you could create a single package and run it on everything from an IoT Raspberry Pi all the way up to a Surface Hub or a HoloLens.
Or the Space Shuttle, Windows Space Shuttle.
The Windows Space Shuttle. Oh, gosh, you gave that one away.
There we go. Lost our jobs.
Yep. But the point, you wouldn't do that, of course. I mean, Space Shuttle doesn't exist. Let's just clarify that point. But if right the way across all of these different product families, at a binary level, this is one package, and you can create an app that is built entirely from the Universal API set that will run on all of those devices. So this is a schematic of the API set and the kind of the relationship between them. So at the top there, at the base of it all, if you've got the Windows Universal API set, and underneath that, we have got, so you can think of that in terms of in a class hierarchy sort of way. That Windows Universal API set is the common Windows APIs that are available across all Windows 10 devices.
And we're saying that many apps may only use that and not actually leverage these extensions that we're talking about. They could just use the default UWP Surface API.
Now the team have announced, the product group have announced that have supposed this idea that 85% of all of your API needs will be satisfied by the Universal API set. I know you disagree on that. And
I do. It's closer to 86 in my testing.
Yep. Okay. So, but what's in that other 15% of stuff you might want to do that's not in that core Universal API set? Well, that's these purple families across here. These are the different device families. So desktop PC is actually your PC and large tablets, your convertible devices. The mobile desktop family covers small tablets and phablets and phones, of course. There's the Xbox and the IoT device family, the IoT headless, a variant on that. And then the Surface Hub, the big 84-inch, and I think it's a 56-inch, two big wall-mounted team computers for sort of meeting rooms. And then, of course, we've got the holographic device family. And in future, there'll be other device families as well that will have their own. And you can think of
Windows
these.
Quantum is going
to... The Windows Quantum device family.
Bound to show up.
Another one you've given away.
Oh.
Yeah, that doesn't exist either, by the way.
Not yet.
Not yet.
Yes. Or does it exist and not exist all at the same time?
Moving on. Yeah, so this Universal Windows Platform, like we said, is this guaranteed API service that's the same on all of these devices. So you could build an app for the desktop and the phone and the Xbox and just use APIs in that set. And they are declared as, it's actually a set of API contracts. So drilling down, it's a kind of a contract between the platform and you, the developer, that this universal API set contains these contracts, which inside that has a bunch of APIs, and it's versioned. So this will be revised for, at intervals. So when we release, when we launch at RTM, this will be the first base version of the Universal Windows Platform, and then some period after, some months thereafter that, there'll be a revision with fixes and maybe some additional new APIs, and that'll get a new version number. So when we're building an app, you're targeting a particular version of the Universal Windows Platform.
Well, it's worth throwing out this little tidbit. It might, as a developer, you might think, well, everybody is going to include mobile because that back button, if you're ever going to be on the phone, the back button, you're going to want to handle it. You know that it's in the mobile SDK. But as it turns out, there's a universal back event now that makes it so you don't need the mobile SDK
and that's in
just for that.
Not just for that. So that's kind of an interesting aside, if you like. Yeah. So looking at the dependency, how you declare a dependency on which version of the Windows Universal device family. So this is the generic across the board. This is you're just building against Windows Universal. And this is kind of similar to what you get in the package.apex manifest whenever you do a file new project in Visual Studio. It actually says at the moment, and we're like 2 weeks after build, it says min version 10.0 to 10.069, max version tested 10.0.10.069.0 is what it says at the moment. But we can see going forward actually a situation where you would have the min version is the version that you have actually built against, and this is the version that you guarantee will work. It means that earlier versions, you won't be able to install this version of the package onto the earlier versions. So that's the base version, and then you've got this max version tested on it, which means that you as a developer have also tested it, or kind of giving a, I wouldn't say it's a guarantee, but an expectation that this package will be suitable for running on any future versions of the Windows Universal device family, right up to, in this particular case, 10.5.0. I mean, that's just an example that we pulled out of the air.
In the syntax that you're showing here, it is showing that it's targeting Windows.Universal, but maybe I could also target a specific device family.
Yeah, so it is a target device family. So here we're just targeting the general case. So you're saying this will run on any Windows 10 device.
That's a bold statement.
That's right. You could change that to name equals
Windows.desktop, maybe?
Windows.desktop, which means this. I'm limiting this app to the desktop device family. Now, the way that you will be able to limit app packages that you upload to the store to specific device families, and part of that will be through the store portal, and part of it will what you declare in the package.apex manifest, like here. So there's a story to tell there, which we're not kind of ready to tell the whole story on that.
All right. So now our application is targeting a specific device family. Now we want to be able to leverage what that device family actually gives us. So now I'm on the phone, I want to do the things that a phone can do. Now I'm on the Xbox, I want to do the things that an Xbox can do. I want to extend that basic 85% of the apps, like that surface area, I want to extend that up into the device that I'm running on.
Yeah, so we enable this through something called Platform Extension SDKs. So this is the delivery medium for getting at these extra APIs. What are they? They're device-specific APIs. They are compatible across all devices within that device family. So in this case, they are related to the extension SDK for a device family. And actually, if you look at the graphic there, which is a snapshot from the current tools, you can select at the moment from Desktop Extension SDK, Mobile Extension SDK, and down at the bottom I've got Windows Team Extension SDK checked, which is the Surface Hub one. And just above that we've got the Windows IoT Extension SDK. So these are all package device family extension SDKs. And
adding this in means all of the functionality of that device is now available to you.
Indeed. And you add them, like it is just this add ref. So you add a reference to the extension SDK just the same as you do any other package like SQLite or Visual Studio Test Core or Visual C++. So you treat them just the same. And Jerry's expiring next to me over there.
I'm very, very sorry. It's just these extensions are so neat.
They are.
So they're hard to choke down.
She's choking on the excitement of it all. Stay with us, Jerry. Stay with us.
All right. So one neat thing about these extension SDKs is, unlike when you add a regular reference into a .NET project, it doesn't, I might add functionality for a specific something. And if that's not installed on all the other devices, now it means your binaries will no longer run on those other devices. Well, that's not acceptable to us. We need to be able to bring these extensions in for the phone, let's say, but still my binary needs to run on the Surface Hub just fine.
Yep.
And so we have this idea of shims, and kind of explain to us, how is it that this is possible?
Yeah. So looking at this graphic here, we've got the desktop, mobile, Xbox, and any more of the device families, and all of them, of course, have got Windows Core underneath them, the Universal API set.
Yeah.
And in the UWP, we've got the whole bunch of the Universal APIs, and you can build your app against this 85 or 86% of all the APIs you ever need, and that could be enough for you. But then you might also want to reference the extension SDK for a specific device family. So you add that reference, and that adds in these extra APIs into the package that you're building.
Now, looking at it right now, it looks like there's a problem. I've added that functionality in desktop. If I go over to mobile, it's going to be missing. So it's going to be an incompatible binary.
So if you try and compile it in this state,
yes,
well, the compiler won't let you. In these particular cases, it will not like that. So what we're doing when you're adding an extension SDK is actually you're referencing the metadata for those APIs, so that the compiler is just happy. It sees the phone hardware back button API, the signature for it. You can compile code into this one binary that references that API, and the compiler's happy, IntelliSense is just happy, and so we can build that package.
So the hard work then is inside the extension. The extension then exposes the API, but it is responsible for whether or not it's implemented on the device that you're currently running.
That's right. So when you get to the actual device, where it's running, it could be running on a desktop, it could be running on a mobile. Whether that API is actually sort of realized, is actually implemented on, is of course down to which device it's running on. So the runtime support is the variable bit of this, if you like.
So as a developer, there's a new set of APIs now that I can run, and I can call those in a way that are gated or not gated, and it's sort of, I guess it's up to me?
Yeah, so we talk about determining which APIs you can call freely. And the implication of that is that actually there's going to be some situations where you cannot call APIs freely. So
freely meaning you don't have to test for it.
You don't have to worry about it. So any API that's in the universal API set is across all devices, so you can just call them freely. They're going to be on all Windows 10 devices, so you can just call them.
But the Xbox Avatar API is not.
No.
And I can call it freely?
Well, only if your app package is only targeting the Xbox. Okay. Then you can add the extension SDK. You can just write your code against the universal APIs and any of the APIs that are in the Xbox extension SDK. But it's never going to run anywhere else, so you know you've not got any kind of a problem.
But what if I do want it to run somewhere else?
Well, exactly. So if you've got, as in many cases, we're going to have an app that you want to run on, the common case is going to be desktop and mobile. So you're going to have an app that you can run on the phone, and also it can adapt.
That's got to be 84% of the scenarios out there.
Yeah, we're firmly in the 80s there. Yeah. Yeah, so that situation, but you do want to call some of these, like hardware back button, the camera button APIs, only on the phone. Well, this is where you will need to write some code to gate calls to those extension SDK APIs to make sure that at runtime, you only try and actually use those APIs in the place where it's intended to be used.
The important differentiation is we talked about the #if and how that was a compiler declaration that said create two different binaries. One if it's on the phone, one if it's on the mobile. That's not what we want. We want a single binary, so we can't have these compilation directives. We need some sort of runtime testing.
Yeah. And that runtime testing is an API called the windows.foundation.metadata.api information. This is the tool that you will now use. This is the runtime equivalent of #if, if you like. Much more sophisticated than that. So, but you can see it's got a bunch of methods on it. The one you'll use most of the time is type present. Now, how do you do it? So this is the pattern for using it. This is how you gate calls to an API that's in a extension SDK.
Okay, so this looks like maybe it's returning a simple Boolean, is type present.
So is type present is simply saying, is this API, can I use it? Are we currently running on a device where this API is available?
So this is awesome. I'm still using the hardware button camera pressed event, even though I'm on a device that doesn't have a camera pressed event supported.
No. So if you're running this on a phone, then you will hook up the hardware button's camera pressed event, and you can do whatever it is you need to do. If you run this same app on a desktop, well, there is no hardware buttons camera button, so this event will never get set up.
So it still compiles. It just isn't running.
Yeah. So this is where you'll have an experience you're offering to your user that's unique to the people who are using your app on the phone, and you're not breaking your app, which clearly won't have the ability to press a camera button. You may put a software take picture, you use the camera capture UI or something to on a tablet, you can still take pictures, of course. We're not saying that it has to be completely different. You'll surface that functionality in a different way. So this is what we mean by lighting up your app on particular devices. You're giving the best possible experience. You could just put a take picture button on the screen for both, but that would be lazy. You want to actually allow the user on the phone to use the camera hardware button because it's there.
Right.
Make use of it.
So the problem has been solved. You are the developer and you don't want to accidentally create multiple binaries to complicate your world. Instead, you want to create one with runtime testing. That's what we get with API information. API information tests your APIs at runtime. Beautiful.
That's what it does. So it's going to be a powerful tool for you in solving these writing code around these situations. Right, so in a particular app, which extension SDKs do I need? Just to stress, we've said this a few times, if you're only using the APIs that are in the universal API set, well, you don't need to reference any extension SDKs. So just because your app's going to run on a phone, you don't absolutely have to reference the mobile extension SDK.
Right.
But you will need it if you want to use the specific APIs that are only applicable to those devices. How do you find out? Well, in the MSDN docs, and this is up online already, if you look up for the docs for a particular class, it will give you down in the information, at the bottom of the page, there's a section called requirements, brackets device family, and it will give you the name of a device family. And it's worth mentioning at this point as well, actually, that a particular API, not this one, this one, the hardware buttons, is phone only, but certain others, Exchange, ActiveSync, I forget the full name of the example, that's not in the universal API set, but is in both the desktop extension SDK and the mobile extension SDK. So APIs are not unique to an extension SDK. They can turn up on more than one device family. When
you do add them, though, the API still has the namespace that you expect for it to have. So as you interact with it, you got it from this extension or you got it from that extension. It doesn't matter because the way that you use it is the same regardless of where it comes from. We're talking about extensions specific to devices, but there are also extensions, of course, specific to functionality. I might be adding, for example, the extension for the Connect. I might be adding the extension for some third-party piece of work that I need, right? Or some sort of authentication or something like that.
That's right. That's right. If you want to have a look at dig down as well, so the documentation is one way of finding out where, if you know what a particular API is that you want to use. But if you want to drill down into what is actually inside of a particular extension SDK, well, there's a good tool is just the good old-fashioned object browser. You can drill down into, in this case, this is a Windows.phone.phone contract, which is one of the contracts. In fact, it's the only contract, I believe, in the mobile extension SDK. Don't quote me on that. Might have to check my facts.
It was true yesterday.
It was, but certainly most of them. Anyway, so you can drill down and have a look. That's one way of doing it.
All right. Well, that's a lot of talk. I think it's okay to actually see this happen.
Right, so I've got an interesting demo here. Let's switch over. This application, I'm just going to walk through it, just allows us to explore actually the visible bounds of your app and to look at some of the chrome around a window. So it's a multifaceted demo, this, but happens to use a little bit of adaptive code in it and some adaptive UI, actually.
Okay.
So here we go. In the background here, in the main page, we've got on Navigator 2, we're trying to manipulate the status bar.
So the status bar in the window.
Yeah, but here we've got an error. Tightening status bar could not be found in Windows.UI.View Management. That's because I haven't referenced the extension SDK where that sits, which is the mobile extension SDK. So we can add a ref. And now, in a minute, that red squiggle will disappear because there we go. IntelliSense said, okay, I know what that is. And this will run now on the phone.
And so that's the status bar up at the top, right?
Status bar is the bit at the top of the page.
How many bars, your battery.
Yeah. So here we are. So there's the status bar at the top, and we can actually manipulate it. So we can actually manipulate the app bar on the bottom. This is sort of got a fun app list, and you can look at the visible bounds, the effective pixel size of the view.
Oh, nice.
And we can go down. Here's the status bar. We can set the background. We can hide it. We can show it. So we're now using the calls to manipulate that. Now, that's great, and this, of course, is a universal app, so we can run it just the same. Just stop that.
On your local machine?
On the local machine.
Oh, nice.
There we go. Run it on the local machine as well, and we can do the same thing.
I've never seen the status bar on a local machine.
Well, yes, you're kind of getting ahead of me there, because in a minute, what you'll see as we try and run this thing, in our On Navigator 2, we're trying to manipulate the status bar, which, I'm waiting for it. Here we go, type load exception.
Oh boy.
So this is what happens when you try and call a device family-specific API on the wrong device family. So we're running on desktop. So this is why we have to gate that call, and I've got it up here in there, with a call to API information is type present. So now at runtime, we're saying, have we got this API?
So you won't get an error loading type because you won't be loading that type.
Not trying to load the type, exactly. And now the app will load and we can do the same stuff, except you'll notice that we can still do the app bar stuff that's down the bottom, and we can still, there's some stuff that's specific to this one actually. Extend the view into the title bar, there you go. We can hide that, and then we can change the background color of the of those buttons. Those calls do work for mobile as well, but
no
have
status
different
bar.
But there's no buttons. What happens to the UI to manipulate the status bar? Well, that's because this is a multifaceted demo where I'm also doing some adaptive UI stuff. So I've got, this is what we looked at in the adaptive UI. We've got our visual state triggers where we're looking in, here we are, we're doing a trigger. Are we running on desktop? And if we are, we're collapsing the visibility of the status bar controls. Yeah, a custom trigger.
All these things play together so nicely.
Oh, it does so nice. So there's our status bar controls. So we're hiding or showing it depending on the value of this custom trigger, which is checking which device family we're running on. So this is Jerry showed this in the last session. Here's a custom trigger, inherits from state trigger base, and we're simply looking to figure out which device family we're running on. And that's the code that allows you to do that. If it is the device family you're testing against, it will set active to true, otherwise it will set active to false. And here, just go back to this again, we're testing for device family of desktop. And if that is true, then we're going to collapse that bit of UI.
So there's two parts here. You're showing the information, API information, and you're showing a custom trigger.
Yeah, so it's a multifaceted demo. So this is why it doesn't show on there. And just to emphasize the point, it does show on device family mobile. And I'll just launch up, and here it comes up again. And those checkboxes, the status bar ones, are there because that's a bit of adaptive UI there. So there we go. That's a nice kind of demo. That and there's lots of other cool stuff in there. Like I said, it's pretty good for figuring out the effective pixel width and height of a page as well. So
yeah, that's a nice clean demo. So adaptive code and adaptive UI, very nice. Okay, so let's talk about versions because I know that's a tricky subject.
Yep. So that was an interesting example. That's a device family adaptive code, but there is version adaptive code as well. What do we mean by that? So we're into a new world where the device, the APIs that you are building against, the platforms, is going to be revised much more rapidly than it used to be. So we used to have sort of .NET versions would come out aligned with big versions of the operating system. And we have .NET 4.5.
Big monolithic upgrades.
Big monolithic updates. But we're now into a new world of more of the Windows, the platform as a service, and the UWP is kind of continuously being enhanced and adding new stuff. And we're going to be issuing new libraries with new functionality. And a lot of this is going to happen out of band, which means that we have to, as developers, cope with a world that's kind of a little more volatile than it used to be. So you can use this adaptive code for that sort of thing as well. So the idea here is that you have issued an app out that works at the current revisions of the platform, and then 6 months down the line, a new version of the platform revision comes out. But you still need to support people who haven't quite upgraded yet, so haven't got the new update. So you want to be able to support down-level clients and up-level clients, and on the up-level client, make an experience that lights up your app and take advantage of maybe some new methods, some increased functionality, that kind of thing.
So there's a combination of information in your application. So you say, wow, that's a lot of shuns, isn't it? There's a combination. And what you have is the UAP or the UWP version that you're targeting, as well as the target for the APIs that you're going to use. So a couple of things happen. The first thing that happens is, as the APIs are revved, you're able to say and declare that I want, as of here, I want those APIs. And so as the APIs are revved, they actually expand, and they don't unwind all their past capabilities. And so there's a mode called quirking mode inside outside of these packages. And so the dependencies you have on there, look at the version of the platform that you're expecting to run on. So for example, let's say that the do something method that I'm in charge of in the API is getting better and better. And so I will have the do something method do A, but in the next version it's going to do A and B. The problem is you've written your application to rely on only A, but that's okay. Because it's in quirks, it goes back to the version that you're expecting and it behaves exactly the way that you want it to. So I can say, for example, I want starting at this version and anything forward, because anything forward I know is backwards compatible because it sniffs out the version of the platform that I'm relying on.
Yeah, that's right. So the kind of pattern that you're going to use in code is a bit like this one here. And I've chosen an example of a scanner device contract, just as an artificial example.
Okay.
And you're looking at you've got a new version 3 that's just come out, and you want to sort of offer to users who have already got that version of the hardware available on their device some new feature. So you're going to call the API that's present in the version 3 of this scanner device contract if it's available. On the device. But for people who haven't yet upgraded, then you're kind of still going to offer whatever behavior it was before, the kind of the not quite so good scanner experience, whatever that might be. But so this is the kind of pattern. I guess another use of the API information is API contract present, where you're just using that override saying not only is it present, but I'm looking for a specific version of it.
Or it may even be that there's something a little weird about that particular version, and so you handle that weirdness, but you don't need to handle it in all the other versions. Yeah. Weirdness meaning?
Idiosyncratic.
Very good.
Yeah.
Oh my, your grasp of the language.
Oh, well.
Unbelievable. All right. Do you remember shared projects? So I have a multiple head project and then that shared in between.
Yeah, so kind of bringing this almost back to where we started. What about shared projects? Do they still have a place in the UWP world? Well, yeah, if you want to. They're just a way of organizing your code. And there are going to be cases where you're going to want to, if you've already developed an 8.1 project.
Don't lose out on that opportunity.
No, you still want to support that, and you've still got people running, and still running out there at 8.1, and you obviously want to keep supporting that app. Then you might very likely want to create a universal Windows 10 version of that app alongside it. So you're going to end up with this kind of structure quite likely, where you've got a Visual Studio solution that includes both heads.
Yeah.
A universal one, which obviously could in theory run across phone, tablet, whatever, right the way across the board. And you've also got a Windows 8.1 app, which would only run on desktops and large tablets, desktop and tablets running Windows 8.1. But you've got a lot of code that's in the shared project. And if you remember what I said before, anything that's in a shared project is just basically block copied into those projects that reference it. So in that case, inside the shared project, the whole compilation time selection, the #if thing, #if, still is the tool you're using, but you're selecting code before it gets compiled in that case.
And I see you've introduced a new compilation variable, the Windows_UAP.
Yes.
So I guess that way I can have my #if in the shared, but still be able to use new APIs.
So the pattern here was down in the shared project you'll use the #if to separate code that's only going to be included into the UWP head. So it's using the old terminology. UAP has been supplanted by UWP, but at the moment the tools haven't caught up. So you're doing that, but within that #if block, you could still then have calls to the API information API and do UWP adaptive code within that. Sounds kind of complicated, but it all makes sense. Yeah.
And so that syntax, you would have your elif go to Windows UAP like this. And then you just start using API information just like you were in the previous one. You just aren't using it you are now using it in a shared project.
So you're combining compile time selection and runtime selection in that case.
I suppose a spoiler alert is when we start talking about porting your Windows 8 apps over to Windows 10, a lot of this is going to be happening.
Yep.
The idea of multiple heads, you had 2 heads, one for Windows, one for shared. You're going to add a third, one for Windows 10 at a minimum. You can still start reusing all that shared code.
Yeah, and of course, just to further muddy the waters, you could have separate heads for specific device families in the universal world as well.
You might just want that because of you don't want to overcomplicate your UI.
Yeah, that's right, and whatever works for you. So the tools will allow you to create the organization of the code just the way you want it.
So that was good. We looked at Windows 8 and the things that we got to do there, and we can kind of see the legacy of Windows 8 coming with us. So we have shared projects and the ability to jump in between. All of that functionality, none of it is gone. And so you still have a lot of capabilities that we inherit from Windows 8. That's really nice. And then we talked about what if the default API surface just isn't enough. You do want to leverage all the APIs and capabilities of a device. That's where extensions come in, and we specifically refer to those as extension SDKs.
Yep.
Then adapting the code, that was a very useful at runtime specifically.
Yeah, that's right. And the two flavors of that, there's device family adaptive code and version adaptive code.
Yeah, that's right.
And then we just wrapped up with a quick look at the shared projects thing. So that was good. That actually rounds up the adaptive story for Windows 10.
And as a reminder, we talked about the concepts of designing an adaptive application, all the things to think about. Then we talked about the UI tricks and all of the approaches we would use with the new functionality inside XAML. And then this, all the adaptive code behind the scenes to make sure you leverage APIs and don't make it so your application is not compatible on all the devices you want to target.
Great. Thanks. Right, so we're going to take a short break, and we'll see you back to pick up on the next module.
Perfect. See you soon.